You cannot secure what you cannot manage, and you cannot manage what you cannot see. As organizations mature in DevSecOps, one pattern becomes increasingly common: tool sprawl. One team adopts a SAST tool, another prefers a different SCA platform. Cloud teams deploy separate misconfiguration scanners. Container teams choose their own runtime solution. Compliance introduces yet another dashboard. Soon, you are not managing DevSecOps, you are managing tools. This lecture is about how you, as a leader or enterprise architect, define a DevSecOps tooling strategy that avoids fragmentation, supports governance, and scales intelligently. Tool sprawl rarely happens intentionally. It usually begins with good intentions. A team wants faster scanning. A security team wants deeper visibility. A cloud team wants specialized controls. A compliance team needs reporting features. Each decision appears reasonable in isolation, but over time you accumulate overlapping functionality, duplicate alerts, conflicting metrics, integration complexity, increased licensing costs, training overhead, inconsistent reporting. From a leadership perspective, tool sprawl increases operational risk and decreases clarity. When 5 dashboards tell different stories, which one represents reality? Fragmentation undermines governance. Why tooling strategy is an architecture decision? DevSecOps tooling is not a procurement decision. It is an architectural decision. You must consider integration across pipelines, identity federation, logging and telemetry consolidation, policy enforcement consistency, data retention alignment, regulatory reporting requirements, operational ownership. If each team chooses tools independently, you sacrifice enterprise coherence. Enterprise architecture must define principles before tools are selected. Tools should support architecture, not dictate it. Platform consolidation does not mean reducing functionality. It means integrating capabilities into fewer, more cohesive platforms. Advantages include unified visibility, centralized policy enforcement, consistent metrics, reduced integration overhead, lower training complexity, simplified governance reporting. For example, instead of separate tools for SAST, SCA, container scanning, and ISC scanning, you may evaluate platforms that integrate these capabilities into a single security layer. Consolidation increases control and reduces noise, but consolidation must be deliberate, not reactive. While consolidation is valuable, over-consolidation can create dependency risk. If one platform fails or lacks innovation, your entire security posture may stagnate. As a leader, balance centralization of governance, flexibility of execution, avoidance of vendor lock-in, architectural interoperability. You should design your tooling ecosystem to be modular with clear integration points. Strategic platforms should integrate through APIs and standardized telemetry, allowing adaptability without chaos. Consolidation should improve resilience, not concentrate fragility. Before evaluating tools, define principles such as security tools must integrate with CI/CD pipelines natively. Tools must support automated policy enforcement. Metrics must feed centralized dashboards. Identity and access control must integrate with enterprise IAM. Logging must support SOC visibility. Tool data must support compliance reporting. When principles are clear, vendor selection becomes objective. Without principles, selection becomes preference-driven. Architecture must precede acquisition. One of the greatest risks of tool sprawl is fragmented visibility. If SAST results are in one system, container vulnerabilities in another, cloud misconfigurations in a third, and runtime alerts in a fourth, leadership cannot see systemic risk trends. Your strategy should ensure centralized telemetry aggregation, unified dashboards, correlated risk scoring, cross-domain visibility. Security is systemic. Visibility must reflect that reality. Disjointed dashboards create blind spots. DevSecOps tools must integrate seamlessly with pipelines. You must ensure tools provide APIs or native pipeline integrations. Security feedback is delivered early. Enforcement thresholds are consistent. Developers do not require multiple interfaces to interpret results. If tools disrupt developer workflows excessively, adoption declines. Tooling strategy must consider developer experience as much as governance. Friction undermines maturity. Tool sprawl often increases costs quietly. Multiple licenses, overlapping capabilities, redundant integrations. As a leader, periodically evaluate which tools provide overlapping functionality, which tools are underutilized, which tools deliver measurable risk reduction. What is the total cost of ownership, including integration and training? Tool rationalization is not about cutting costs arbitrarily. It is about optimizing value. Financial discipline strengthens architectural discipline. DevSecOps tools themselves become part of your supply chain. If your security platform is compromised, attackers may gain insight into vulnerabilities across your environment. Your tooling strategy must include vendor risk assessment, secure integration practices, data residency considerations, access control enforcement, incident notification agreements. Security tools must be held to the same standards as the systems they protect. Trust must be verified. Tool fragmentation often results in inconsistent policy enforcement. One scanner blocks high severity vulnerabilities. Another merely flags them. Another categorizes severity differently. You must ensure unified severity classification, consistent risk thresholds, standardized remediation timelines, central oversight of policy configuration. Consistency strengthens credibility. Inconsistent enforcement erodes trust. Many enterprises operate across multiple cloud platforms and on-premises systems. Your tooling strategy must accommodate multi-cloud visibility, hybrid infrastructure scanning, centralized policy governance across environments, consistent reporting regardless of platform. Fragmented cloud-specific tooling often multiplies complexity. Architectural coherence across environments strengthens scale. Tool sprawl affects culture. When developers must navigate multiple dashboards, they become fatigued. When alerts duplicate across tools, they lose confidence in findings. A streamlined tooling ecosystem reduces cognitive load. Clear signals promote disciplined response. Your strategy should prioritize clarity and usability. Security effectiveness depends on adoption. What good looks like? In a mature DevSecOps tooling strategy, core security capabilities are consolidated where practical. Tools integrate natively with CI/CD workflows. Telemetry feeds centralized dashboards. Policy enforcement is consistent across domains. Identity integration is standardized. Costs are rationalized. Vendor risk is assessed. Architecture principles guide selection decisions. Tools support strategy. They do not define it. Ask yourself, how many security tools operate across your DevSecOps ecosystem? Are there overlapping capabilities? Is security telemetry centralized? Do executive dashboards provide unified visibility? Are policies enforced consistently across tools? Does your tooling strategy align with enterprise architecture principles? If the answers reveal fragmentation, you have an opportunity to strengthen coherence. Tool discipline reflects leadership discipline. If this lecture has challenged your perspective on DevSecOps tooling, act strategically. Conduct a tooling inventory. Identify overlaps and gaps. Define enterprise architecture principles for future acquisitions. Consolidate where appropriate. Standardize policy enforcement. Align telemetry with centralized governance. Do not let tool sprawl define your security posture. If you found value in this session, subscribe to the DevSecOps for Leaders playlist like this video so it reaches more leaders and architects. and share your experience in the comments. Are you dealing with tool sprawl in your organization? In the next lecture, you will explore incident response in DevSecOps environments and how pipeline compromise and secrets exposure change the response model.